Oh, how long is he gonna be?
It's 11 o'clock. Wait for 1 more minute. Mm, 20. All right. Good morning, everyone. Happy Monday. And I can see that 20 of you are already here in the call, and we are still waiting for others. But since our class is only 15 minutes and we need to review chapter 4 today in those 15 minutes, so we can start our class. So last time we did the review for chapter 3, and if you notice on your canvas, the solutions for Bayes rule practice problems were uploaded, and the announcement was also sent that the test is on Wednesday, and it will open at 10 o'clock, 10 to 4, and you can take your test 2 in the same format as your test 1 on Launchpad. We will send another announcement tomorrow about the test, which will be exactly the same, but just a reminder that test will open on Wednesday at 10 and will be closed at 4, and extension will not be provided until there are sufficient documents for that. So try not to miss that part. Again, your test count as a big chunk of percentage for your final grade. So today we are going to review chapter 4, and I'm going to record this. First recording was already uploaded under your test 2 module, and today's recording will be uploaded there as well. So today's review session, Miss Minion is going to conduct that, and I will upload that recording there in chapter 2 module as the last time. If your cameras are on, please turn your cameras off so that you will not be your face will not be on the recording. So I'll hand over to Miss Minion, and then I'll start the recording. All yours, Minion. Let me turn off my camera.
All right, do I need to turn off mine too? Monica? Okay, I think I'll just turn off mine too. I've been sitting in the background for a long time, and now finally I'm on the front stage. So let me just go ahead and start, and also let me know that if my voice is choppy or if you can't see what I'm writing on the screen. Okay. So thank you. So today I'm going to go over chapter 4. In chapter 4, we basically talked about 3 big parts. The first part is probability models, and then also we talked about probability rules, and we also talked about the random variables. So now let's start with probability models. So we introduced the probability models as the description of random phenomenon, and it consists of 2 parts. The first part is the sample space S, which is the set of all possible outcomes, and it consists of the sample space S consists of a set of events, and also the event is either one or a set of outcomes of a random phenomenon. And when we talked about the event, we introduced disjoint event, which means there are no common outcomes between two events, or general understanding, we say two events cannot happen at the same time. For example, being a freshman and also being a sophomore. I think that's generally not um, a common outcome, right? And also, if a person is dead or alive, they can't happen together, right? So those two events are disjoint. And if we try to demonstrate that in a Venn diagram, it would be it will be something like this. So we have our sample space here, right? And we say event A and event B are disjoint if they don't overlap with each other. Okay. And um, other than disjoint events, we also talked about independent events. So basically, it means two events or more events that are not related. Or say, if we have two events, A and B, the outcome of event A does not influence the outcome of event B, or vice versa. Okay, but they could be overlapped, which means they could be not disjoint but independent. So, for example, I remember Mrs. Goel was talking about this homework problem with me, that the first character of license plate and also the color of the car are two independent events. All right. And then the second component of probability model is probability for each event in the sample space. The portion, the probability is basically the portion of times the outcome would occur in a very long series of repetitions. And I apologize for any background noise here. All right, so since we started to talk about probabilities, let's review the probability rules. Okay. The first probability rule says that for any event A, the probability of that event ranges from 0 to 1. It cannot be less than 0. It cannot go over 1. And the second rule says that the probability of the whole sample space is equal to 1, which is saying that the sum of all possible outcomes is 1, right? And for any disjoint events A and B, we have the probability of A or B is equal to the probability of A plus the probability of B. And get used to the notation here. The little coupling means union, and it means A or B. Okay. And let's say A and B are not disjoint, or we have no knowledge of um, the disjointability, then we have to use this formula below, which is we have to subtract the parts that they overlap with each other, right? The next rule says the probability of the complement of an event A is equal to 1 minus the probability of A. And now let's assume that we have two independent events, A and B, and then we can calculate the probability of their overlap part is equal to the multiplication of the probability of these two events, right? And these 5 are some basic probability rules. Down below, we have two other rules. One is the conditional probability, and one is the Bayes rule that we talked a lot about. The Bayes rule is actually built on the conditional probability. So the conditional probability is what it says here. The probability of event B given event A is equal to the probability of A intersect with B divided by the probability of A. And with this being said, we have the general multiplication rule here, which says the probability of intersection of A and B is equal to the probability of A times the conditional probability of B given A. Okay. And then next we have the Bayes rule, which is written here. Here is a more compact way of expressing it, but if you have a hard time understanding it, then you can just look at the latter parts that could make more sense. All right, and later on we are going to go over a example for this part, so you should have better understanding of that after that. And plus, Mrs. Goyle has gone over a lot of examples on Bayes rule, so make sure you go over that when you study for the test as well. Okay. But any questions so far? I guess we're all good so far. And
Do you have any questions? So far, whatever Ms. Lee explained, if you guys have any questions or in between, if you have any questions, please feel free to stop and ask. If not, I guess you'll proceed.
Yeah, please do that. Please just shoot any question whenever you have one. Okay. All right, then we move on to the last part of chapter 4, which is random variables. And we define the random variables as numerical variables that describe the outcomes of a chance process. We introduced two random variables. One is discrete random variable, for example, the number on a die. Okay, and we also introduced the continuous random variable. For example, the weight of teenagers of age 16, right? And within the continuous random variable, we specifically introduced the normal random variable, and we say a random variable follows a normal distribution with a mean of mu and variance of sigma squared. And there is a special case of normal random variable, which is called the standard normal random variable or standard normal distribution. This is when your mean is 0 and your variance is 1. And whenever you're given a normal random variable with mean mu and variance sigma squared, you can standardize your x by using this formula right here. And this process is called standardization. And with this, you can get your z-score for x. So let's say we have your x follows a normal distribution with mean, say, 2, and then the variance being 9. Then you would standardize x by subtracting your mean here, which is 2, and then you divide by sigma, which is the square root of your variance. And this one is easy, which is 3. But here you get this z-score for your x, and furthermore, you can look for the probability for the z-score. But that's what you are going to do with specific questions. Okay. Any questions so far? Okay, I guess not. So we just mentioned the probability distribution for the normal random variable, and the probability distribution of a random variable is actually the probability models of that random variable. And remember, we talked about there are 2 parts in probability model. One is um, the sample space. For here is all the possible random variable values, and then the probability for each outcome or for each random variable value. Okay. And for the probability distribution, we use parameters to describe the shape of the distribution. And we introduced the mean, which is the measure of center, and also the variance, which is the measure of spread of the distribution. And for discrete case, we give out the formula to calculate the mean and the variance. For the mean, we sum up all of the multiple of the random variable and their probabilities. And for the variance, we use this formula right here to calculate. Okay. And we also talked about the rules for mean and variance, which are not included in this test, but it is a very useful tool either later in this class or if you learn further with statistics. So make sure you understand and memorize them as well. Okay, so the rules for the mean is we have a random variable x, and you want to calculate the mean of the random variable a plus bx, where a and b are constants here, then it is just equal to a plus b times the mean of random variable x. And when you try to calculate the mean of random variable x plus or minus y, then it is just equal to the mean of x plus or minus the mean of y, right? And for the variance part, if you want to calculate the variance of a plus bx, again, a and b are constant here, you would just do b squared times the variance of random variable x. And if you were to calculate the variance of x plus minus y, then it would do the variance of x plus the variance of y plus or minus 2 times the correlation times the standard deviation of x and the standard deviation of y. Okay, but again, the rules for mean and variance are not included in this test, but you could be foreseeing that in the final exam or later in your study too. All right, any question regarding this part?
And one thing I want to add here, yeah, as you looked in your homework and quiz questions, at some places they are using the rule for the variance, but the question is asking to find the standard deviation of x plus y or x minus y or a plus bx. So in that case, we do not have the rule for standard deviation. You need to go through the variance, and once you get the answer, take the square root of that.
Right. Let me jot it down here, and I think I will upload this document after the class. Is it okay that I do that, Monica?
Yeah, yeah, please do that. That would be great, in fact.
All right, and I'll just write it here. Standard deviation. Deviation. I don't know how to spell. It's equal square root. All right. I hope this is clear.
Yeah.
Okay. All right. I think that's all the concepts that we talked about um, in chapter 4. Is there any question? Do you guys want me to go over more about the concepts? Just let me know. But before we go into the sample question, I think I can elaborate more for the conditional probability and the Bayes rule here. So I always think that Venn diagram is a go-to tool when you try to understand conditional probability and Bayes rule. So why don't we draw it out here? So let's say we have the sample space. And I think Mrs. Goel did this in class as well. I just want to reinforce it. So this is our sample space S. And let's say the sample space S is partitioned, which means it's segmented into n parts. Let's call it A1, A2, until AN. Okay. And we also have an event B here. Okay. So let's say the conditional probability of, let's say, B given A1, it would be equal to, using the conditional probability rule here, we have the probability of B intersect with A1 divide by the probability of A1. Okay. Does that make sense?
Yeah.
Good. And that's for the conditional probability right here. And from there, you can also use the general multiplicative rule here to get, let's say we want to get the probability of A2 intersect with B, then it would be equal to the probability of A2 times the conditional probability of B given A2. Or if you're given the probability of B, then you can do the other way, A2 given B. Okay? And that's the conditional rule. And once we expand our conditional rule, we get the Bayes rule. So let's say we want to find the probability of A3 given B, right? But we are only given the probability of the AIs and also the conditional probabilities of events B given each AIs. Then we can use the Bayes rule, say A3 times probability of B given A3. And then in the denominator, you would have A1 times probability of B given A1 plus the probability of A2 times the conditional probability given A2. and plus until an times the probability of B given an. All right. I hope this is, yes.
Is there a sample question that uses Bayes' rule that you might be able to go over?
Yes, I will go over that in just a minute. And so this is just helping you to understand what is conditional probability and what is Bayes' rule. But also when you're doing the problems, either in your test or later on when I demonstrate the sample question, we are going to use tree diagram to help us to solve the problems. So I believe that you still remember how Mrs. Goel did the tree diagram in her classes or in the past few classes. So the tree diagram looks more like this. So you have your sample space, and then there would be your B1 and B2. And for each B1 and B2, you will get A1, A2, and A1 or A2. There could be multiple, but this is a general idea. And here you would have the probability of B1, and here would be your conditional probability of A1 given B1. Okay. And here as well, I'm just not writing it. Right. So I guess we're done with the concepts, and you guys are longing for the sample practice problem. So let's go ahead to the problem right here. But before that, is there any questions? Okay.
Any questions? No. Okay.
Okay. All right. Let's go for the practice question then. In a particular pain clinic, 10% of patients are prescribed narcotic painkillers. Out of all the people not prescribed painkillers or pain pills, 5% are addicts. Out of all the people prescribed pain pills, 8% are addicts. And there are actually several steps. So the first question is asking, what is the probability of patients that are not prescribed narcotic painkillers? So why don't we try to label them as A and B, so later on it's easier for us to note it, right? So let's assume the patients are prescribed with the painkiller is B1. Okay. And so that the opposite or the complement of B1 here would be the patients that are not prescribed painkillers. Let's say it's B2. And the patients who are addicts would note it as A1. And the complement of that would be non-addicts, and let's denote it as A2. So now the first question is asking, what is the probability of patients are not prescribed narcotic painkillers? And so we just said this event, we denote it as B2, which is a complement of B1, prescribed narcotic painkiller. So could anyone tell me which probability rule this one is using? Any ideas?
Would it be conditional?
You're going too far. We're not there yet. But so for this one, we're saying that 10% of patients are prescribed with narcotic painkillers, right? And we're saying that the complement of event B1 is actually B2. So which rule is using the complement probability?
In other words, she is asking what is the probability that the people who do not prescribe painkillers, we have the probability of the patients that are prescribed with painkillers. How can we
90%.
complement it? Perfect.
Right, it is 90%. So we're actually using the third rule of the probability rules, which is 1 minus the probability of B1, right? And we know that the probability of B1 is 10%, so we get the answer as 90%. Okay. And then the next question is asking, what is the probability of patients that are prescribed painkiller, which is B1, right? And are addicted, which is A1. So, which is asking, what is the probability of B1 intersect with A1, right? So here, what do you say that we use? Or which rule that we're applying right here? Any ideas?
How do we find the intersection?
Yes. How do we find the intersection?
You guys remember the multiplication rule?
Probability of B times probability of A.
That could be it, but we don't know if A1 or B1 are independent or not. But actually, the problem told you that they're probably not independent, right? So if the two events are not independent, what would we use?
Is it division?
Close. The general multiplicative rule comes from or derived from the conditional probability rule, right? So remember, for the after the conditional probability rule, we have the general multiplicative rule, which says the probability of B1 times the probability of A1 given B1, right? Do you think we are equipped with the conditional probability of A1 given B1, which is the conditional probability of addicts given the patients that are prescribed with painkillers or pain pills?
Minion, do you want to make a tree diagram so that it's more?
Oh yes, that would be helpful. So let's do the tree diagram here. So out of all the patients in the pain clinic, we have the patients that are prescribed with painkiller, which is B1, right? And then we also have the patients prescribed with not prescribed with painkiller, which is B2. And the problem told us that 10% are prescribed, and we just calculated that 90% are not prescribed, right? And then later on, it tells us out of all the patients or people not prescribed pain pills, 5 are addicts, right? So people are not prescribed, and given that they're not prescribed, 5% are addicts. And this is actually our conditional probability of A1 given B2, right? And then also we have people that are not addicts. And it also says out of all the people prescribed pain pills, here B1, 8% that are addicts. And also we have non-addicts too. So this is the conditional probability of A1, whoops, given B1, right? So now you see how tree diagram can help you to solve the problems with conditional probability or Bayes rule, right? So now, do we know the probability of B1?
10%.
Yes, 10%. And do we know the conditional probability of A1 given B1?
8%.
Yes, 8%, right? And so we get the probability of the patients that are prescribed B1 and are addicts A1 as 0.8%, right? Any questions so far? Good, good. All right, let's move on to the last part of this problem. So it asks if a patient is an addict, what is the probability that they will be prescribed pain pills, right? And again, we can use our tree diagram here to help us understand or help us to solve the problem here too, right? So we were given addicts, the probability of addicts given prescribed or not. Now we're asking if we're given the information that the patient is an addict, what is the probability that they will be prescribed? But this would be A1 and prescribed is B1, right? So the question is asking you to calculate the probability of B1 given A1. And what do you think the rule that we're applying here be?
It would be the second rule on the conditional probability, right?
Very close. We're actually using the Bayes rule because observe here we are only given the probability of this one and then the probability of that one and also the probability of B1 and also the probability of B2, right? So we are actually applying Bayes rule. What we want to do is to like what I'm sorry if I pronounce your name wrong, Joshua?
It's
Right. Just Josh?
Josiah.
Josiah. Okay. Like he mentioned that we can use the conditional probability rule here, which is B1 and A1 divided by the probability of A1, right? However, we don't really know the probability of A1, but we just did calculate the probability of B1 and A1. So what we can do is to rewrite this using the Bayes rule plus the probability of A1 given B2 times the probability of B2. Does it make sense here? So this part is actually the probability of A1 given B1 times the probability of B1, which we just calculated in the previous part. All right. And in this formula, everything we need is in this tree diagram already. So what we need to do is to plug it in, right? So the probability of B1 and A1, we just calculated as 0.8%. And same here, 0.8% plus the probability of A1 given B2, which is 5%, times the probability of B2, which we calculated in part 1, which is 90%. And if you do the calculation, you should be get 15.09%. And that will be your conditional probability of B1 prescribed pain pills given the patient is addict A1. Okay. I hope everything is making sense to you. And this is all that I have to review for you. I strongly suggest that you go over the basic concepts in detail and try to work on the examples that Mrs. Goel went over in the classes, as well as your homework and your quizzes. And I hope this review session is helpful. And that's all I have for today.
Thank you.
Thank you.
And let me share my screen now.
Okay. I will stop it now.
Thank you. Anyone has any questions?
Yeah, I had a question for chapter 4. I know that the past chapters have had a lot of sample problems. It looked like they were like photocopied. I didn't really see that for chapter 4. Were you planning on doing that, or was there something that I was missing in Canvas? I just didn't see that many of the practice problems as there were from last time, and I just wasn't sure
Yeah,
about that.
so chapter 4, as I mentioned earlier in the class, and I uploaded the problems on Canvas also regarding the Bayes rule, and I uploaded the solution, or you can say step-by-step solution for those problems. And since there are 2 homework assignments and there is a quiz on chapter 4, and all these assignments have more than 20 questions, so there are a lot of problems. But again, if you want to do more problems, as discussed in the syllabus and on your launchpad, I assign a couple of assignments that are optional to you. And in that, there is learning curve as well as practice quiz. And you can go over those problems as well. And Stat 108 chapter notes, there are some problems there as well.
Okay.
And, yeah. So if you have any other questions, is that answer your question though?
Yeah, it does.
Anyone else has any other question? So I received a couple of emails regarding one of the question in your quiz, quiz 3. So I'll quickly go over that so that it makes sense to whoever does not understand that problem. And I will upload a step-by-step solution for a couple of problems from your homework, from your quiz, sorry. And as I mentioned in the email, that chapter 4, 4.4, 4.5, question number 1 was a little confusing to some of you. And I think it's not explaining it well, that A, B, and D, how these 3 events or the D is talking about the first two events. So the explanation was given to you all in the announcement. But again, if you miss that question, you will get the credit for that particular question. So in your quiz, there is a question. You guys can see my screen?
Yes.
Okay. So there is a question that is given to you. Uniform distribution is given, and this is given too here, and it says 0.5 and it was 1.5. And this was given, and the question is asking what is the probability that x is between 0 and 3/4. Or you can write it that x is between this. If we have this uniform distribution, we know that the area under the uniform distribution is one whole. So since we do not have a complete rectangle shaped distribution, let's do some work here to see what information we have. So now I'm talking about two rectangles. This is one of my rectangle, and the area is one here, and area is one here. The question is asking you to find the area from here to here. So finding this is not the hard part. You can find this easily because you have the length, which is 0.5, and you have the width, which is 1.5. This is given to you, right? And finding this one, and especially this one, because you are looking for only this part. If you know the area for this and you add this one, you will get the remaining one. So how much is this? You can subtract this one. You get 0.5, and you know that if this is 0.5, this is also 0.5. You can check from here also. So the length, if this is 0.5, width is also this one. So if you're finding this one, you can find this part. And this is 0.25 times 0.5. And when you look at this, if you want, you can make it like this one. So this part is your 0.25 times 0.5, which will be 0.125. And then you find the area from here and add this one, that will give you the area. So it is not asking you between this and this. So read the question carefully. Instead of 0.75, it just give you that x is between 0 to 3/4. So fine, if you want, you can convert into decimal and then you can check. Also, if this is the probability, if we are talking about a discrete probability model, let's say I'm just using some numbers, and let's say I take the probability, I'm just taking 4. So we know that this is a right probability model, and if you are working with the right probability model, you need to satisfy two rules. The first rule is that probability of the sample space is 1, and all the probabilities are between these two. And this table or this discrete model satisfied both rules. So it is a legitimate probability model. Let's see if the question is asking what is the probability of x equals 2. I can find, it's a discrete probability model. I can find the probability at x equals 2. Similarly, if we are talking about a continuous probability model, and we talked about this before also, when we are looking at the probability at a particular point in the continuous probability model, it is always 0 because we do not know how many possible outcomes are here and we cannot assign the probability. So if I write x equals greater than equal to 2 or x equals greater than 2, they both means the same. So if you are looking for the probability of this or this, there is no difference. But if I am asking you this part here, let's say 1. So here I'm asking you probability of x1 and above 1 in the table. So the probability of x1 and more than 1 is only 2. So probability of x equals 2. And if I'm just asking you probability of x greater than 1, so that means this is not included. I'm talking about only this. Also, If the question is asking you, what is the probability of x greater than 1.2? And we know that when we are looking for 1.2, it's between 1 and 2, but I do not have the probability of 1.2. So I will just write the probability of x equals 2. So 1.2 greater than 1.2, this is the only I have. If the question is asking probability of x less than 1.2, we are talking about probability of x0 plus probability of x1, because 1.2 less than 1.2 is everything on the left side. So that's, you have questions like this in your quiz and you worked on it, but I just want to make sure that you understand this part. So let's say if this part is not given, first of all, you need to find the missing probability. And if the question is asking you to find the expected value, once you find the missing probability, then you multiply. And there is another question in the quiz where it's asking, or it's giving you that we have 10 balls with 3 different colors, red, green, and blue. And it's saying that how many red, how many green, how many blue you have. And it's saying that if you're getting a green ball or a red ball or a blue ball, you win a certain amount of money. So it says, let's say $2, $4. And if you have a blue ball, there is no money. So again, the probability table is not given to you straightforward in this one, but you can do that. You can find the probability of winning $2 is 3 out of 10, because I have 10 balls altogether, and this is 1 out of 10, and this is 6 out of 10. You have the probability, you have the winning money, and then you can find the average. So I'll stop here. And if you guys have any questions, feel free to send us an email. And again, your test is on Wednesday. Testing window is given to you. And I will stop here. Anyone has any questions? Thank you, everyone. Have a wonderful day.
Thank you.
Just to clarify, the testing window is going to be during class on Wednesday?
So I send an announcement regarding that as well, and we talk in the class. The testing window will be from 10 to 4. And you can take it during any time, but if you do not have any time, you can work during your class time.
Okay, thank you.
You're welcome. Anyone has any other questions for us? Thank you, everyone.